Your AI agent just forgot what you told it 3 messages ago. You gave it context, it nodded along, and then it acted like the conversation never happened. If you've built anything beyond a simple chatbot, you know this pain intimately, and you've probably realized that memory isn't a feature you bolt on later. It's the difference between an agent that feels intelligent and one that feels broken. Here's the thing most tutorials gloss over. Memory isn't one problem, it's several. There's short-term memory, which keeps the current conversation coherent. There's long-term memory, which lets an agent recall facts across sessions. And there's what you might call working memory, the scratchpad an agent uses while reasoning through a multi-step task. LangChain and CrewAI both tackle these, but they come at the problem from completely different philosophies, and understanding that difference will save you weeks of frustration. Let's start with LangChain, because it's the more granular of the two. LangChain treats memory as a modular component you explicitly wire into your chain or agent. You've got classes like ConversationBufferMemory, which simply stores the full message history and stuffs it back into the prompt. That works until your conversation gets long and you blow past the context window. So LangChain gives you alternatives. Conversation Summary Memory, which uses the LLM to compress older messages into a running summary, and Conversation Buffer Window Memory, which only keeps the last few exchanges. You choose the strategy, you tune the parameters, you own the trade-offs. Where LangChain really flexes is long-term memory through vector stores. You take past interactions or documents, embed them, and store them in something like Chroma, Pinecone, or FSS. Then when a new query comes in, LangChain retrieves the most semantically relevant chunks and injects them into the prompt. This is retrieval-augmented memory, and it's powerful, but notice what's happening here. You are the architect. You decide what gets stored, when it gets retrieved, and how it's formatted. LangChain hands you the building blocks and a lot of rope. CrewAI takes a strikingly different stance. Because CrewAI is built around the idea of multiple agents collaborating on tasks, memory is designed to be more automatic and role-aware. Out of the box, CrewAI gives you short-term memory that tracks the current execution, long-term memory that persists learnings across runs, and entity memory that specifically tracks people, places, and concepts the agents encounter. You don't hand-assemble a memory pipeline. You essentially flip a flag, enable memory on your crew, and the framework handles storage and retrieval behind the scenes. That automatic behavior is CrewAI's biggest strength and its biggest catch. When you enable memory, CrewAI uses embeddings and a local storage layer to let agents recall relevant context from previous tasks, which means a researcher agent can remember what it found yesterday and a writer agent can build on it. It feels almost magical for multi-agent workflows, but the trade-off is control. You have less visibility into exactly what's being stored and retrieved, and when something goes wrong, debugging that opaque memory layer is harder than inspecting a LangChain vector store you built yourself. So what should you reach for? If you're building a tightly controlled application where you need to know precisely how memory behaves, and you're comfortable assembling components, LangChain gives you that surgical control. If you're orchestrating a team of agents and you want sensible memory defaults without micromanaging every embedding, CrewAI gets you moving faster. Many serious builders actually use both, letting CrewAI coordinate the agents while LangChain manages the retrieval logic underneath. The real lesson is this. Memory isn't a checkbox, it's a design decision. Understand the layers. Pick the framework whose philosophy matches your project, and your agents will finally stop forgetting. If this cleared things up, let me know which framework you're leaning toward, and I'll see you in the next one.